Hi, my name is Nati, and we will be doing problem number 6 on the test review, which is to find the interval of convergence and its radius of the power series. And this is the problem we are given. And looking at it, I can tell we're going to use the ratio test depending on its powers. And I won't be writing divided by an. I will actually be writing this multiplying by its reciprocal. So it'll look a little like this. Limit as k is approaching infinity, absolute value 3x minus 2, k plus 1, because it says over here an plus 1, k plus 1 times the reciprocal, which is k, and 3x minus 2. Now I'll just be focusing on what is cancelable, which will be these k's, which will leave your remaining of this because you're still left with 1. Now, you could say these k's cancel out, but because of this plus 1, that is not possible. So we'll just leave them be to look a little like this. K infinity, k plus 1 times 3x minus 2. And I kind of just separated the k's and the x's just to keep them cleaner. And it'll make sense in a while. So if you try to put the infinity into this will all go to 1. And why is that? Is because this is essentially going to be infinity over infinity, which is L'Hopital. So it all goes to 1. If you take the derivative of k, it'll be 1k, and this one would also be 1k, which would separate these, which would cancel them out, making it k over k, which equals 1. Of the k's, we can just focus on the x, or the absolute value of 3x minus 2, which we can set them less than 1 and greater than negative 1, so we can solve for our interval of convergence. Just simple equation. Now we have our endpoints. So now that we have our endpoints, we can test them into the original problem, which will be which is very similar to the alternating series test, which you should put as alternating series test and P series, because in your note card you might have them combined, but it's nice to see them clear out because they're two different tests. So therefore, this series converges conditionally by the alternating Now we can test out our another point where we let x equal 1. Which will hence just be 1. And we can use the simply p series. Which then you will say that this series diverges by the p series. And good. Find our radius of convergence, which I like to do as 1 minus 1/3 over 2. That way I can just see 2/3 times 1 over 2 equals 2 over 6, which equals 1/3. So my radius of convergence is 1/3. And you're good.